guys, it's IDW, and today we are going to be talking about input and output, which is probably the single most important part of a computer. More on that later, but also I might as well announce now that this is the final actual PowerPoint explanation video that I'm going to be doing in this series, as far as I can tell. I might do one on debugging, but hopefully I'm not going to do one on that. Because that's kind of a mess, and I think I can explain it well enough. And if I go through with what I have planned to debug my computer, then it should go just fine. So yeah, anyways, continuing along, let's just start out with a brief overview of the subject. Input-output is basically, if we go back to the workshop analogy, which we have not done in a very long time, it's like the shop part of the workshop, where you actually go in and buy this chair that we've been talking about this whole series for some reason. And also you might have delivery people who are bringing in different parts for more chairs. This has been a long series. But anyways, you sort of get the idea. It's the way the data goes in and out of the computer. And as I said earlier, it is probably the single most important part of a computer. And I'm sure there's a whole bunch of people who would debate that, but here's my reasons. The first one is that it allows us to actually use the Turing machine. Because it's cool if we can have a Turing machine that can solve any problems, but if that Turing machine can't show the solutions to those problems to us, then why do we have it in the first place? So that's the first reason why I/O is so important. The second I/O is more from a business perspective, because if you think about it, a customer is significantly more likely to buy a computer that has a really good I/O than a couple of levers like you would have in Minecraft. So yeah, it's just important because your product's going to sell a lot better if you have good I/O. And then finally, good I/O allows you to quickly and efficiently interact with the Turing machine. And the reason for that's significant is that, as opposed to just plain having I/O, which is the point that we're making up there, if you have good I/O, then you're going to be able to solve a lot more problems in a lot less time with good I/O. So yeah, anyways, moving on, there's generally three types of input-output that we're going to talk about. There's opcodes for the I/O, showing registers, and memory-mapped I/O. So first of all, using opcodes for input-output is relatively simple. You just have one opcode that displays some data and another opcode to send in data. And when you first look at this, you think of this as just being a simple method, and it's actually not the most ideal method if you want to have a simple I/O, which we're going to have in our computer. But when you're doing complicated tasks with screens, this is pretty darn valuable. And even then, this method isn't used too much. Again, this is really just a simple, quick solution that you can use, and not one of the most efficient ones. Now, even a step behind that is just taking your register values and just sending them out. And this is something you'll see on really old computers, we're talking literally comparable to Minecraft computers. You just have a few displays that show what your registers are. You send in punched tape, something from the 60s old. So yeah. So once again, that's probably not what you want to do unless you're doing something really simple and dirty. But finally, the one that most people do is something called memory-mapped I/O. And memory-mapped I/O is extremely useful because, if you think about it, you could say that whenever you're reading from an memory address that you call input-output, then you could say that you would be sending an output in. And whenever you're writing to that address, then you would send it to the I/O. To the display. So if you think about it, that makes it so that we don't actually have to do any of this fancy stuff with opcodes. We can just have a memory address that we just say is the I/O. So yeah, that's the idea behind memory-mapped I/O. And most computers in general use this because it's really effective and it doesn't really hamper your really anything. It's just an extension of your memory. So yeah. Anyways, that actually concludes the just sort of general part of this episode. if you're watching this for my redstone series, but we're going to be talking about displays in modern computers now, because I decided, hey, this is pretty cool and this is pretty darn important, so we might as well talk about this, because there's no way that we're going to be able to do any of the ridiculous stuff in Minecraft, but I thought I might as well mention it because it's pretty darn cool. So, first of all, let's think about an image, because an image is just represented as a specific arrangement of pixels. Like if you're in black and white, then you could see exactly how you could transmit that into a binary number. Like if you have a 2 by 2 image, then you would have 4 bits, and the first cell would correspond to the first bit, and the second cell would correspond to the second bit, the third cell, the third bit, and so on and so forth. Wow. But anyways, so basically, even with colored images, you can represent them with a number. And the way that you do this is rather complicated, and it's too complicated for redstone, which is why we're not talking about it, but basically you just have a lot more information. Like, in the example that I just gave you, you would have, like, one pixel has 1 bit of information on or off. In a color display, though, you have to have 4 8-bit values, 3 of which are the primary colors, and one of them is the darkness or shade or blackness or whatever. So, yeah. That makes it so that you would have 32 bits in a single pixel. And if you think about it, just considering how annoying that is on its own, it's just not practical in redstone at all. And there's only 16 colors, so yeah. Anyways, next thing is that it's all handy-dandy that we can just take a number and have it be an image and have it be represented by a number. The problem is coming up with an image that actually means something, because it's really cool that we have all these different images that you can display on a screen at once, and it's amazing that you can have such insane control over them. But the thing is that, remember what I was talking about there being 32 bits in a single pixel? Just think about how many pixels there are on the screen that you're watching this on. And I'm sure your mind is just exploding with the amount of information that takes. And the thing is that of all those things, a lot of them are really random and really weird. And so the thing is that you'll have something called, you'll go through a process called rendering to come up with a number that actually represents an image that's meaningful. And like when you're using like an image manipulation program like GIMP or Paint, then you're going to be just coming up with that number to represent it and rendering it in the program. But usually this is actually done by your graphics card, which is actually a Turing machine itself that's specialized to come up with the images like that really quickly. Because if you think about it, you can do the processor like taking 2 images and overlapping them. You just need to know where to put them if you're putting them on top of each other. So yeah, it can be a bit complicated, but that's why you have a graphics card, because you need to render stuff. And once again, this is actually the really hard part about making images, because displaying stuff on the screen, nah, it's not very hard at all. You can just send in a number and it'll display it. But actually coming up with a number that's meaningful is the reason why, even though we have such ridiculous computers, it's really easy to notice when something like that happens. So yeah, hopefully I did a good enough job of explaining that, but with that, that concludes the entire video here. So yeah, I hope you guys have enjoyed, and I'll see you guys next time.